This is Precalculus section 6.2, day 2. Today we're going to be discussing applications of right triangle trigonometry, so how to use right triangle trig in your everyday life. Two things that are pretty important about right triangle trig are the angle of elevation and the angle of depression. The angle of elevation is the angle formed between the horizontal line of sight, abbreviated HLS, and the object above. So for elevation, we're looking above. Think elevators, how elevators take you from the bottom floor to the top floor. An example is the angle created when a woman spots a cardinal on top of a building. So this is, the dotted line I'm creating now is the horizontal line of sight, abbreviated HLS. The angle she makes to the top of the building is the angle of elevation. Discussing angle of depression, which is the angle formed between the horizontal line of sight and the object below. So you can think the level that's the line that is at eye level is the horizontal line of sight. An example is the angle created when a teacher looks at a student seated in a desk. So the horizontal sight looking down is the angle of depression. Think of when you're depressed, you're feeling down, so look down for angle of depression. We're going to be using the angle of elevation and the angle of depression to solve some of these word problems given. So for example 1, it states from the top of a lighthouse 20 meters high, I'm going to underline it because it's important information, a sailboat is sighted having an angle of depression of 4 degrees. Angle of depression of 4 degrees. We're trying to find how far the lighthouse is from the boat, or how far from the lighthouse is the boat. So we're trying to find the distance from the lighthouse to the boat. We'll label that D. So information we know is that the lighthouse is 20 meters high, and we know from the top of the lighthouse to the bottom of the boat, there's an angle of depression of 4 degrees. So I need to draw in my horizontal line of sight, HLS for short. So I know that this degree measure right here is 4 degrees. Using knowledge from geometry, if we have two parallel lines, the horizontal line of sight and the line of the ground, those two are parallel. If we have opposite interior angles, they're congruent. They're both the same thing. So the measure of the angle by the sailboat is 4 degrees. Using the angle of 4 degrees, we need to look at the other measures that we know. We know 20 meters, which is the opposite side. And what we're trying to find is the adjacent side. If we know opposite and adjacent, we might as well use tangent, because thinking of SOHCAHTOA, tangent uses opposite and adjacent. So we'll take tangent of 4 degrees, which is opposite over adjacent, so 20 over D. Multiplying by D and dividing by tangent of 4 gives us D equals 20 divided by tangent of 4 degrees. Remember, we're dealing with degrees, not radians, so we need to make sure our calculators are in degree mode. So then D equals 286 feet. So we know that from the lighthouse to the boat is 286 feet. For example 2, it says when the sun's angle of elevation is 38 degrees, a building casts a shadow of 45 meters. We're trying to find out how high the building is. So we're looking for height. We know that the building casts a shadow of 45 meters. And this is the shadow of the building. The angle of elevation, so from the building looking up, is 38 degrees. We know that this angle measures 38 degrees. We're trying to find height. So think of the things we know. We know that the shadow is 45 meters. This 45 represents the adjacent side. So we know the adjacent side, and we're trying to find the opposite side. So think of your trig functions that you can use adjacent and opposite. So we know that we will be using tangent because tangent is TOA, opposite and adjacent. So we'll be taking a tangent of 38 degrees. Since tangent is opposite over adjacent, we'll be taking h divided by 45 meters. Simply multiplying by 45 meters on both sides gives us h equals 45 times tangent of 38 degrees. Again, making sure your calculator is in degree mode because 38 is being represented in degrees. We are left with h equals 35.2 meters. So we know that the height of the building is 35.2 meters high. For example 3, it says a 530-foot guy wire is attached to the top of a 155-foot tower. We're trying to determine the angle the wire makes with the ground. So if here's our wire from the top of the tower to the bottom of the ground, we know that the tower is 155 feet, and we know that the wire is 530 feet. We're trying to find the angle that the wire makes with the ground. So the angle with we're going to write theta for our missing angle. Thinking of the information that we have in order to solve for theta, we have the opposite side and we have the hypotenuse. So we have opposite and we have hypotenuse. Think of SOHCAHTOA. Sine is the only one using opposite and hypotenuse. So we'll be taking the sine of theta, and since sine is opposite over hypotenuse, we'll be taking 155 over 530. In order to solve for theta, we need to take the sine inverse of both sides. So we're left with theta equals sine inverse of 155 over 530. Making sure when we take the sine inverse of 155 over 530, we are left with theta equals 17 degrees. So we know that theta equals 17 degrees.